Hi, I'm Juha and I'm a hockey player here at USC. I will be going through some physics concepts and examples with you this semester. And remember, just like on the ice, there's no such thing as luck in physics. Just keep your head up and work hard.
In this example video, I will show you how to use the matrix formulation to calculate the cross product of two vectors. So we have these two vectors a and b, like shown here. So let's draw them in the coordinate axes. So a is 5i minus 4k, so it's 5 to the right, and then minus 4 in the z direction, so it goes somewhere there behind. So it's basically it's in the xz plane with that angle from the x-axis. And the other one, the b vector in blue, so that's going to be minus 3i, so minus 3x and plus 2y, so that's going to be the xy plane somewhere right there. So if this is the x-axis, continuing just makes an angle there like this. So it's B and that's A. And now we would like to calculate the cross product of this one. So let's go ahead and use the matrix form. So cross product of A and B is of course a vector C. And now let's build our matrix. So first the coordinate axes, y, j, and k. And then what is our vector A? 5i, so you have 5 here, but there's no j, so we have 0, and then k is minus 4. And then b, minus 3i, 2j, and 0k. So now we just evaluate this determinant, and let's keep track with the signs. So everything from I comes with positive, j negative, and k against positive, and so on. So first of all, we develop with the respect of I. So we, in our minds, we cancel this column and this row like this. We are only left with these 4 elements. So what we have here, we have the diagonal products starting from the top left. So 0 times 0 is 0. Minus the other product, minus 2 times minus 4, so it's minus 8, like this. And then change colors here. So we develop with respect to j, so we cancel this row and again that column. So and j comes with minus, so minus j, diagonal products 5 times 0 is 0, minus 3 times minus 4 is 12, so that product is negative, so negative 12. And then the third option, or the third development with respect to k, so we have to cancel this column and again this row, so we only have these 4 elements. So first of all, positive k, because we have positive here, and the diagonal products 5 times 2, that's 10, minus 3 times 0, that's 0, like this. So what do we get? We get 8i, 12j, plus 10k. So does the direction of this vector make any sense? So according to our right-hand rule, the direction of the c vector is when we point our fingers to the a, the right-hand finger to the a, and curl it towards b. If you do that with me, you'll see that your thumb is pointing somewhere out of the screen and towards your eye. So we're in the quadrant where all the coordinates are positive, and that is in fact the case here, so at least that checks out. And if you would like to calculate the magnitude of this cross product, we just calculate the magnitude of C. So that would be just using the Pythagorean theorem. That would be h squared, or square root of h squared plus 12 squared plus 10 squared. And the direction of our vector is, of course, whatever is the direction of C. And now you might remember the other definition of cross product. So in that case, we had the magnitude of C was A times B, magnitude of A, times magnitude of B, times sine between the angle of the two vectors. So if you want to do it this way, we would have to calculate first the angle between these two vectors, A and B, which are just random vectors. And that would involve calculating a dot product. So you wouldn't save too much effort if you went this way instead. So for all the generality, I would encourage you to use this matrix form whenever you are developing or calculating cross products. It is more general and a lot of times saves you time as well, although it might look tedious to begin with.